Question 1, we're given this polynomial and it's a curve, and it says that it passes through the point P where x equals -1. Question 1a is asking us to find dy dx, so just differentiate, and we just go along and differentiate. So 13 will go, 18x gives us 18 when we differentiate it. 3x squared is going to give us 6x, so plus 6x, and then minus 4x cubed is going to go to -12x squared, and that's 3 marks. Then says show that the point P is a stationary point of the curve and find the other value of x where the curve has a stationary point. So for it to be stationary when the gradient dy dx is equal to 0. So what we're going to do is we're going to put the dy dx equal to 0 and find the values of x that satisfy it, and hopefully one of them will be -1 because that's the point P. So therefore we're going to let minus 12x squared plus 6x plus 18 equals 0. And what I can do with this is I can divide through by 2. Sorry, I can divide through by 3, which gives me minus 4x squared plus 2x plus 6, and then I can divide through by another 2. That's going to give me -2x squared plus x plus 3. And then I can multiply through by -1, and that will change the negatives to positive and the positives to negative, so I get there. And hopefully I can factorise this. So we put it into 2 brackets. Look at it for a moment. It's going to be 2x there, and it's going to be -3 and plus 1. Does that work? 2x. Yeah, that's fine. Okay. So therefore y equals 13 plus 18x plus 3x squared minus 4x cubed. This curve here is stationary when x equals -1, because if I put -1 into the right bracket I get 0, and also when x is equal to 3/2, because when I put 3/2 into the left bracket that one goes to 0. So they're the 2 stationary points. Now for part C, we want to find the 2y dx second differentiation. So I'm going to differentiate this that I had before, 18 plus 6x minus 12x squared. The 18 is going to go, the 6x is going to go to 6, and the -12x squared is going to go to -24x. So I get 6 minus 24x. So that's the second differentiation. And at point P, when x is -1, So at point P, the second differentiation is equal to 6 minus 24. I'm going to sub in -1 there, because that's the values of x at point P. And I'm going to get 24 plus 6, which is 30. Okay. Now, for part CII, we found that the second differentiation is 30, which is greater than 0. And because the second differentiation is greater than 0, we can say that point P is a minimum. Okay, and that's question 1 done. For question 2, I've just got to manipulate these surds. So the first one, we've got to square what's in the brackets. So when I square what's in the brackets, I get 3 squared, and I get root 3 squared. So this is going to go to 9 times 3, which is 27. On this second one, I'm going to have to rationalise the denominator. And to do this, we multiply by 1 so that the fraction isn't changed. But we write 1 slightly weirdly. We write it as 3 root 3 minus root 7. So it's the same as the denominator that we have, except the sign has changed. And we write the same on the bottom, so that it's actually the same on the numerator and the denominator, so it's just 1. So I'm multiplying by 1, so it doesn't change the fraction, except when I multiply it out, we'll see that we get rid of the surds on the bottom. So let's first of all do the top. I'm going to multiply this out like I would a double bracket, like a quadratic. Okay, so I'm going to do 4 times 3 root 3. 4 root 3 multiplied by 3 root 3. So 4 times 3 is 12. And then root 3 times root 3 is 3. So that's 12 times 3 is the first term. And then I'm going to get 4 root 3 times minus root 7. So that's going to be negative 4 root 3 root 7. And then I'm going to get 3 root 7 multiplied by 3 root 3, which is going to give me 9 root 7 root 3. And then finally I'm going to get 3 root 7 multiplied by minus root 7, which is going to give me negative 3 times 7. And I'll tidy that all up in a moment. On the bottom I'm going to get 3 root 3 multiplied by 3 root 3. Well, we've already done 3 root 3 multiplied by 3 root 3 in the first part of the question, so I know that's just 27. And I'm then going to do 3 root 3 multiplied by minus root 7, which is going to give me 3 root 3 root 7. I'm going to do 3 root 3 multiplied by plus root 7, so those are going to cancel, which is why the surds go on the bottom. And then I've got root 7 multiplied by minus root 7, so that's going to be negative 7. Okay, and then I'm just going to tidy up the top and the bottom. So 12 times 3 is going to be 36. And then 3 times 7 over here is going to give me negative 21. So I've got 36, take away 21, which I think is going to give me 15. So it's going to be 15, take away, and then I've got 9 root 3 root 7, take 4 root 3 root 7, so this is plus 5 root 3 root 7. That's the top simplified. Okay, and then on the bottom we'll see that this and this cancel, so I've got 27 take away 7, so that's just 20. And then finally you should see that I can divide through the top and bottom by 5, and I get 3 plus root 3 root 7 divided by 4. Okay, and in the form that they want, they've put their surds together to give me 3 plus root 21 divided by 4. So m and n are 3 and 4, and that's question 2. On question 3, we're given a line equation, AB, and a coordinate C, which goes through to -7. It asks us to find the gradient of AB. The most simple way of doing this is to just rearrange the line equation so that it's y equals, and then we can just read off what the gradient is. So I'm going to move the x's over, so I've got 2y equals -3x plus 7. And then I'll divide by 2. So I've got -3 over 2x plus 7 over 2. And so we can see that the gradient is the number before the coefficient before the x. So the gradient of AB is -3 over 2. That's question A done. For A part 2, it says the line which passes through C and which is parallel to AB crosses the y-axis at point D. Find the y-coordinate of D. So here we know that we have a line with the same gradient, and we also know that it passes through a certain point. So we're going to use this line equation that you should be familiar with. And I can substitute into there a coordinate that the line goes through and the gradient, and I should be able to get the equation of the line, and then from there find out where it crosses the axis. So let's do that. We have y, and we're going to take away y1. y1 is going to be -7, so this is going to be plus 7 there. The gradient is the same as in the line we've just had, and then I'm going to put in x, and I'm going to take away 2. So that's the equation there of the second line, which is parallel but goes through that point. I'll rearrange it here for y equals again and have it in the same form as above. But it's just asking me, find the coordinate D, and that's where it crosses the y-axis. Well, when it crosses the y-axis, x is 0, so let's put that down. When the line crosses the x-axis, if you think about it, then, sorry, it's when the line crosses the y-axis, isn't it? When the line crosses the y-axis, then x equals 0. So we're going to go and put x equal to 0 in this line equation that we just had. So therefore, y plus 7 is equal to -3 over 2 multiplied by 0 minus 2, so that's just -2 in there. So I get y plus 7 is equal to 3, because the negatives are going to cancel and the 2's are going to cancel, and finally y equals 3, take away 7, so this is going to be -4. Okay, so point D has the x coordinate 0 because it crosses the y-axis, and the y coordinate -4. Okay, and then for part B, the line with the equation y equals 1 minus 4x intersects the line AB at point A. Find the coordinates A. So we're given this line, y equals 1 minus 4x, and it intersects the line we had at the start. Well, let's write it in the way that we rewrote it. Y equals negative 3 over 2 x plus 7 over 2. It was plus 7 over 2, I think. Plus 7 over 2. And where these two lines intersect, they're going to have the same y and x values, because at that coordinate they're going to have the same y and x values. So I can solve these by simultaneous equations, or I can use substitution. I think I'm going to use substitution. So with y equals 1 minus 4x and y equals negative 3 over 2x plus 7 over 2, and then because they're both y, I can write down that 1 minus 4x has got to be equal to negative 3 over 2x plus 7 over 2, because they've got the same y value. And now I'm just going to try and find out what the x value is. Okay, so I'm going to multiply both sides by 2, and that will get rid of the 2's on this side. And I'm going to get the x's all onto one side. I think I'm going to move them to the right, so I'm going to stay with 2 on this side. I'm going to add 8 to this side, so I've got 5x plus 7. And then I'm going to take away the 7 from the right hand side, and that gives me 5x is equal to negative 5. So x has got to be equal to negative 1. Okay, so I've got the x coordinate. Now to find the y coordinate, I can just sub this x value back into one of these line equations up here. It doesn't matter which one. It's probably easy to sub it into the one on the left. So I'm going to sub that into y equals 1 minus 4x. So y is equal to 1 minus 4, and I'm going to change the x to a minus 1, so I want that value there. So this is going to be y equals 1 plus 4, y equals 5. And so I've got the x value and the y value. And so point A has the coordinates negative 1 and 5. And finally, for the last part of this question, it says point E has coordinates 5k. So we've got another point 5k. Given that CE has length 5, find the two possible values for the coordinate of k. Okay, well, we have the point C, and we're told its coordinates 2, negative 7, and what we're saying is the distance from C to E is 5. Okay, the distance from C to E is 5. So I have these two coordinates. Now I can write down the distance using Pythagoras. You might remember it as a formula. It's essentially Pythagoras, and it's the difference in the x's squared plus the difference in the y's squared, all square rooted. So that's the distance between any 2 points. Now we want the distance to be 5, so let's make the distance 5, and let's now sub in the x values. So I'm going to say it's going to be 5 take 2 squared, and then the y values is going to be k, and it's going to be take away minus 7, so it's plus 7 there. Okay, I'm going to square both sides. So we've got 25, 5 minus 2 squared, that's 3 squared, so that's just 9, and here I've got k plus 7 squared, and here I'm going to get a quadratic to solve. So now I'm going to multiply out this bracket here. So here I'm going to get k squared plus 14k plus 49, and I'm going to rearrange this into a quadratic that I should be able to solve. So it's going to be k squared plus 14k, and then I've got plus 49 plus another 9, so that's 58, and then I'm going to take away 25, so that's going to be 25 plus 8, so that is that 33, plus 33, I think, yeah, plus 33, okay, and that all equals 0. I'm trying to find the k value that makes this true. It does factorise if you look at it for a little bit. I'm trying to look really at how we could break 33 up, and it's got to be a k there and a k there, and it's got to be plus, and it's got to be 3 and 11. Okay, 3 times 11 makes 33, 3 plus 11 makes 14. So the two possible values of k then you should be able to see are the two values that make this 0, and that's k equals -3 and k equals -11. And that's that question. The first question is asking us to find the gradient of the curve at point P. So to find the gradient, we just differentiate, and can just differentiate y here. So 14 is going to go, I should get -1 minus 4x cubed. Okay, and at point P, x is 1. So I sub in x as 1 because I want the gradient at that point P. So at point P, dy dx equals -1 minus 4 times 1 cubed, and 1 cubed is just 1. So this is -1 minus 4 minus 5. Okay. So the gradient is -5. It says, hence, find the equation of the tangent to the curve at point P. This is similar to the question we've just done. So part 2, hence find the equation of the tangent. Well, we have the gradient. The gradient is equal to -5. We also have 2 points that it goes through, because it goes through point P, and they're 1 and 12. Okay, so I can just use that line equation that we were just using on the previous question, and substitute in the values that I need. So therefore, y take away 12 is equal to -5, x take away 1. Okay. Now it wants the equation in the form y equals, so I just need to multiply this out and bring the 12 across. So I've got y take 12 is equal to -5x plus 5, and then I'm going to bring that 12 over, -5x, and then I'm going to add 12 on, so this is plus 17. Okay, so that's the tangent to the curve at point P. Next thing is we've got to do some integration. Let's come down. So part B says find this value 1 between 1 and -2. We want to integrate 14, take x to the power 4 dx. Okay, so the 14 is going to go to 14x. The minus x is going to go to -x squared. The power goes up by 1 and divide by the new power. And again, the power goes up by 1, I divide by the new power, and I've got to sub in these limits, 1, -2. So let's just do that. First of all, I'm going to sub in 1, so I get 14. I'm going to sub 1 in here, -1 over 2, so let's take away a half. I'm going to sub in 1 here, so let's take away a fifth. So that's me subbing in 1, and then I'm going to take away when I sub in -2. So when I sub in -2, 14 times -2 is going to be -28. When I sub in -2 into the x, it gets squared, so it's 4 minus 4 over 2, so let's take 2. And then when I sub in negative 2 into the x there, I get negative 2 to the power of 5, which is going to be minus 35 over 5, which is going to give me 7, and it's minus 7, and there's a negative in front of it, so I think that's going to be plus 7. Okay, so let's just see what we can do with all this. 14, take away a half, take away a fifth. 14 take away a half is 13.5, and then take away a fifth, it's going to be 13.3. Okay, and then I'm going to take away minus 28, minus 30, plus 7, so that's minus 23. Okay, put these together, so it's 13.3 plus 23, so that's going to be 36.3. I think. So that's the area under the curve between 1 and negative 2. Then it says, hence find the shaded region. Well, the shaded region, this is B part 2, shaded region is going to be the area under the curve, which we just found out. And the line. Okay, well, the area under the line I can find out quite quickly. I can draw myself a little picture. It goes from negative 2 to 1, and it goes up to a height of 12 because I've got these coordinates, and it's a triangle like that. So the area of that little piece there, it's got distance 3 here, it's 12 high, so the area of this piece here is 1/2 3 times 12, so 1/2 of 36, which is going to be 18. Okay, so the shaded region is 36.3, take away 18. $36.3, take 18, which is going to give me 18.3. Okay, and that's that question done. So we're now on question 5, and it's asking us to sketch this curve for 3 marks. So first thing you want to do is draw yourself some axes. Now it's going to be a cubic, because when I multiply this all out, I'm going to get x. In fact, let's just do it. Let's multiply it. Let's multiply it out because it's probably going to be important in the rest of the question. So I'm going to get x times x squared. Take 4x. Minus 2 times minus 2 is going to be plus 4. And so all this goes to x cubed minus 4x squared plus 4x. Okay, but you can see in the form that we've got it in here, we've got x multiplied by x minus 2 multiplied by x minus 2. Okay, so we've got one factor x, and then the repeated roots. Okay, so there's a value. We're looking for the values of x that make this go to 0, and they are when x is 0, because there's an x out in front. So I know the curve goes through 0 there, and also when x is 2, it goes to 0. But I should say that this x minus 2 appears twice, it multiplies twice, so that's a repeated root there, which means that it just touches. Okay, I look at this here and I say that this is positive, so I know that the curve starts up here, it's going to just touch there because of that repeated root, and then it's going to come down and cut there. Okay, So I'm just going to, I've got a mark for the shape of it. I'm just going to mark on here that this point here is 2, 0, and this point here is 0, 0. Okay, let's cube it. And that's question 1. Question A, sorry. So now, for the next part, it says show that x multiplied by x minus 2 squared equals 3 can be rewritten like that. Well, we've already multiplied out the first statement, so let's just write down what we've got to do. So we've got x take 2 squared there equal to 3, but we've already shown the thing on the left can be written as x cubed minus 4 x squared plus 4x, and this is all equal to 3. And then if I bring the 3 over, that equal to 0. I'm done, I've proved it, that's another mark. Okay, so now we're on to part B. Okay. So part B, we're using the same polynomial that we've just shown. Let me just write this out. And it says find the remainder when it is divided by x plus 1. So I'm going to use the remainder theorem here for part I. And it says when it's divided by x plus 1, that means that if I just sub in minus 1 into there, I will get the remainder. Okay, so I'm going to sub in minus 1, I'm going to get minus 1 cubed, minus 4 times minus 1 squared, plus 4 times negative 1, minus 3, let's just work this out, that's going to go to negative 1. Minus 1 squared is 1, so this is minus 4. This is going to be minus 4 again, and then negative 3. I'll put all these together. Minus 1, minus 4 is minus 5, minus 9, it's going to be negative 12. So the remainder is negative 12. Okay, we've got to show that x minus 3 is a factor. So it's the same method, except this time there should be no remainder, should be 0 remainder. So if I can sub in 3, because it wants to show that x minus 3 is a factor, I do the same thing, but I don't want a number at the end, I want it all to go to 0. So I'm going to get 3 squared minus 4 times 3, so this is 3 cubed, minus 4 times 3 squared, plus 4 times 3, minus 3, and hopefully this all goes to 0. So 3 cubed is 27, 3 squared is 9, and then I'm going to times it by 4, so that's going to be take away 36, plus 12, take 3. Okay, and yet that all goes to 0. And then I'm going to just add the statement on here, therefore x take away 3 is a factor of A. Because the remainder's gone to 0, because the remainder's 0, yeah. Okay. And now we want to express P in the form x squared plus bx plus c, okay, and find out the values of that. Well, this is okay because I've just found, or we've just shown that x minus 3 is a factor. So let's just write out P. This is I. So P of x is equal to x cubed minus 4x squared plus 4x take 3, and this should be equal to x minus 3, because I know that's a factor, multiplied by something, and it says it's got this form here, and we've just got to find out what the b and the c are. So I can do this by multiplying out the right hand side and comparing it to the left hand side. Now I'm going to do this the long way, so you can, so it's like a sort of fail-safe method. I'm going to multiply at the right hand side, so I'll get x squared is x cubed, x times bx is bx squared, x times c is cx. I'm going to times it all by minus 3 now, so I'm going to get minus 3x squared, minus 3bx, and minus 3c. And then I'm going to bring together the x cubes. So I've got 1x cubed. How many x squareds have I got? Well, I've got bx squared here and minus 3x squared here. So this is b, take away 3, lots of x squared. How many x's have I got? I've got cx, take away 3bx there. So this is going to be plus c, take 3b x there, and then I'm going to take away 3c right at the end. And now I'm going to compare. I'm going to compare the amount of x cubes I should have on both is the same. I've got 1x cubed in the white at the top and 1x cubed at the bottom here, so that's good. Now here I've got minus 4x squared there and b minus 3x squared there, but they should be the same. So I can write down that minus 4 should be equal to b minus 3, and then I can just rearrange this and find out what b is. So adding 3 to both sides, I get that b is equal to minus 1. Okay, and I can do the same thing here. I've got 4x's here, and I've got c minus 3b here, so I can write down that 4 has got to be equal to c minus 3b, but I've just found out what b is. So this is c, take away 3 times minus 1, so that's plus 3. I'm going to take 3 from both sides, so I should get that c equals 1. Okay, and so I can write down now, go back and say that p can be written as x minus 3, that was the factor we found out earlier, multiplied by x squared plus bx, well b was negative 1, so let's put that in, minus x plus c plus 1. Okay, so b and c are minus 1 and 1. Okay, so that's that bit. And then finally, hence show that the equation has only one real root and state the value of this root. And this is for 3 marks. Okay, so it's saying that this thing has only one real root. Well, here's one real root here. One real root is x equals 3 is a real root. So let's put that down. X equals 3 is a real root of px. So there's the one real root. So we've basically got to show that this bit has no roots. This little quadratic there, it can't be factorised, it can't be split up. It has no roots. So the way to do that is if x squared minus x plus 1 has no real roots, which is what we're trying to show, then the discriminant b squared minus 4ac has got to be less than 0. Okay, so in this case we write down the values of a, b and c. In this case a is equal to 1 because it's 1 squared, b is equal to negative 1, and c is equal to 1. And therefore if I take this and do b squared minus 4ac, I get minus 1 squared, which is 1, take away 4 times a times c, which is 1 take away 4, negative 3. Okay, so b squared minus 4ac is equal to negative 3, which is less than 0, and there we've shown that no real roots. Okay, so p only had one real root, and that was the one we showed earlier. Okay, and question 6 is a circle question. We're given the centre of a circle, negative 3, 1, and the radius of the circle, and then the first thing it wants us to do is express it in this equation form. So you should be able to do this. Let's going to be the opposites, so it's x plus 3 squared plus y minus 1 squared should equal the radius squared, so this should equal 30. Okay, that's 2 marks. That's the first bit. And then we want it in this other form, x squared plus y squared. So all we do here is we multiply this out. So this first bracket is going to get multiplied out to x squared plus 6x plus 9. And the second bracket is going to get multiplied out to y squared minus 2y plus 1. And that all equals 13. Okay. And then I'm going to just rearrange it how they want it. So they want the x squared first, and then the y squared, and then they want the x's, so there's 6x, and then they want the y, so it's minus 2y, and then they want the numbers, so I've got 9 plus 1 is 10, but then I'm going to bring the 13 over, so it's going to be negative 3, and that equals 0, and that's the second part. So m, n and p are integers, 6, negative 2 and 3, that's okay. Okay, so part B, the circle cuts the y-axis at points A and B. Okay, so find the distance A to B. So firstly, let's find out the coordinates of A and B. Where does it cut the y-axis? It cuts the y-axis. We've already done a question like this. It cuts the y-axis when x equals 0. Okay. So when x equals 0, I can just take this yellow equation or any of the equations I've used already. When x equals 0, I just get y squared, because the x squared is gone, take away 2y, minus 3 equals 0. Okay, and this will tell me the y coordinates of the places where it cuts. So I should be able to factorise this hopefully. There's a y there, and a y there. And this is going to be minus 3 and plus 1. Okay, factorises. So the y values are y equals 3 and y equals negative 1. Okay, and if you think about it, so if you think about it, the points A and B, let's just make it more explicit. Point A, we can say, has the coordinates 0, 3, because it's got an x coordinate of 0, and point B has coordinate 0, minus 1, because they cut this where it cuts y-axis. So the distance AB has got to be 4. Okay, the distance from 3 to minus 1 is 4. Okay. Next thing, part C. We want to verify that D, this point D, let's write it down, lies on the circle. Okay, so all I need to do here is sub these coordinates into the equation. So the equation, again, I'll use the same one, x squared plus y squared. What was it? X squared plus y squared plus 6x, take 2y, minus 3 equals 0. I'm going to sub in the x value and the y value, and hopefully it all goes to 0, and that will mean that it's on that curve. So minus 5 squared is going to be 25, 2 squared is going to be 4, and then I've got 6 times negative 5, and minus 2 times negative 2, and minus 3. And we don't know what it equals yet, but hopefully it's going to equal 0. This is 25 plus 4, this is minus 30, this is plus 4, and this is take away 3. 25 plus 4 is 29, take away 30, that's minus 1, plus 4, yeah, equals 0. And therefore D lies on the circle, because it satisfies the equation. Okay, find the gradient of C to D. Okay, find the gradient of C to D. Well, that's okay. We can do that. Let's grab that. I've got point C as the coordinates -3, 1, and point D as the coordinates -5, -2, and then the gradient of C to D, so write it like that, is the difference in the y's. So it's going to be, let's write it like this: y2, y1 over x2 is x1, and then this is going to be 1 take away -2, so it's 1 plus 2, and then the difference in the x's, it's going to be -3 take away -5, so it's +5, so this is 3 minus 4 over 2. Okay, so the gradient is 3 over 2. And then finally, the very last question. Hence, find the equation of the tangent to the circle. Okay, well, let's just draw a little picture for this one, just to get it in your mind. It won't be a very accurate picture. We had the point C, and on it, that's the point C, and also point D. And we've just found the equation of the line that goes from C, or the gradient of the line that goes from C to D. Okay. So if we want the tangent, that line there, okay, the tangent line at D will have the gradient, which is the negative reciprocal of the gradient, because they're going to be perpendicular. It's a right angle there because it's a tangent. So we'll have the gradient -2 over 3. Okay. We also know that it goes through point D. So again, we're going to use this line equation. Okay. And we're going to sub in the values. Y minus y1, well, it's point D. Let's just make a note of that over here. It's going through point D, which was -5, -2. So this is going to be y plus 2 is equal to the gradient -2 over 3, x take away -5, so that's +5. Okay. So that's the equation of the tangent, and you'll get marks there, but we can just tidy it up a little bit by multiplying by 3. Multiplying this out, and then taking the 6 off. Okay. Okay, so finally we're on to this. And the first thing we're given is this quadratic, not a very nice one, and we're asked to express it in the form p minus x plus q squared. Okay, so let's do that first. Now, it's not in a very nice form to start with, so firstly, rewrite this with the x squared at the front, like this. Okay, and we want to complete the square. That's the form that it wants it in. So to do that, we want to take that negative outside, so factor it out, like that, and then complete the square of what's in the brackets and keep the negative outside until the end. So completing the square, it's going to be x plus 5 here, squared. Squared, it's going to give me 25, so I'm going to need to take away 29. Okay. And then I'm going to put the negative back in, and so I will get 29 take away x plus 5 squared, and that's the form that it wants it in. So p is 29 and 5. it then says, hence write down the equation of the line of symmetry to the curve. Well, the completed square form, this bit here, tells you the in this case it tells you the maximum or minimum point. In this case, it's going to be telling you the maximum because it's negative, so it's like a sad face. So it's telling us the maximum, and the maximum of this curve, or the max point, is when x is going to be minus 5, minus 29. Okay, so that's the maximum point, but it's actually after the line of symmetry. Well, the thing is going to be symmetrical about that point, so the line of symmetry, because that's the maximum point, is going to be the line x equals negative 5. Okay. Now for part B, let's just scroll down. For part B, it says the curve C has this equation and the line has this equation. Let me write this down. Y equals k, so that's constant, 4x minus 13. And then the curve C has this equation that we just used. Okay. So show that the x-coordinates for any points of intersection of the curve would satisfy this. So where these things intersect, again similar to the other problem, where these things intersect, they both have the same y values. So y equals this and y equals that. So I can say that k for x minus 13 has got to be equal to 4 minus 10x minus x squared. And now I've just got to manipulate this to try and make it look as it does in the question. Okay, so I'm going to multiply it all out. So I'm going to get 4kx minus 13k on this side, and on this side just have it as it is. Now it's got it all onto one side and all equal to 0, so I'm going to bring everything onto this left hand side. So I'm going to get x squared plus 10x, so this is me bringing the left hand side over, minus 4, and then I've still got this plus 4k x and minus 13k. Okay, and then I'm going to just put all this together. So it's x squared. Now how many x's have I got? I've got 10x plus 4kx. So let me put that in. 10 plus 4k. Lots of x. How many numbers have I got? I've got minus 4 and minus 13. So let's put this as plus. Sorry, I've got minus 4 and minus 13k. So that's going to be minus 4 plus 13k. That's better. Okay, and that all equals 0. And then just a couple more things to do to it to make it look exactly as it is on the question sheet. And that is, keep that as it is. I can take a factor of 2 out of here. And I think they just write this the other way around. Okay, and that's it. Okay, so if they intersect, then that's the equation that tells you where they intersect. Right, part 3. Given that the curve and the line L intersect at 2 distinct points, show that the expression they've got there. Well, if they intersect at 2 distinct points, then the discriminant b squared minus 4ac, it's got to be this time greater than 0. Okay, so I look back at the formula that we've got here. we write down the values of A, B and C. So in this case A is 1, B is 2 times 2k plus 5, and C is going to be negative 13k plus 4. And we want the discriminant to be greater than 0, so we're going to write this down, that 2 times 2k plus 5 all squared, because that's all of B, take away 4 times A, well A is just 1, times C, well that's C but there's a negative in front of it, so that's plus. We want that to be greater than 0. Okay, now we're going to just multiply this out, and again we're trying to make it look as it does on the question sheet. So I'm squaring this, so I'm going to get 4, 2k plus 5 squared. Multiplying this out, I'm going to get 4 times 13, which is going to be 52, okay, plus 16, and that's still greater than 0 if it's going to have 2 distinct roots. I'm then going to have to square this, so I'm going to get 4k squared plus, what am I going to get here, 2k times 5, and that's 20, is it? 2k plus 25 plus 52k plus 16, 0. Okay, at this point I can divide everything through by 4, which is going to save me a bit of time, so it gets rid of the 4 in front of there. This divided by 4 is just 13, and this divided by 4 is just 4. Okay, and then put all this together. I've got 4k squared, and I've got 20k plus 13k, that's 33k. And then I've got 25 plus 4, which is 29, and that's exactly what they wanted us to show. So if it's got 2 points of intersection that are distinct, then has to satisfy that, and that's because of the discriminant. And then the very last question is to solve this. Okay, so to solve it, all we have to do is find, well, first of all we're going to solve, excuse me, so to solve the inequality, we're going to solve something slightly different. We're going to solve that when it's equal to 0, and that will tell us when it's equal to 0, and then we can think about when it's less than 0. Okay, so let's see if it factorizes. It looks like it does. It's not an easy one, but let's just try it. I think this might be 4k and k, and is this 1 and 29? Let's just check that. 4k squared, yeah, 20 and plus 4, yeah, okay, that seems to work. So the places when it equals 0 is when k equals -1, and when k is equal to minus 29 over 4, which doesn't seem very nice. 29 over 4, that's like 7 and a bit. Okay, 7 1/4 minus 7 1/4. Okay, what I would do now is draw a little picture, a little sketch. Okay, and I'm looking to sketch this thing here, this curve here. Now it's a quadratic, it's a positive coefficient here, so it's going to be a smiley face, and I've just found out where it cuts. It cuts at -1, which is going to be about there, and it also cuts at -29 over 4, which is going to be somewhere over here, so it does something like that. I'm just going to mark those points on. So this point here is minus 1, and this point here, negative 29 over 4. And that's, we found the places where it equals 0. But the question was asking us, when is it greater than 0? That's what it asked us to solve. When is this greater than 0? So all I have to do is look at my graph now and say that 4k squared plus 33k plus 29 is greater than 0. These bits here, that's greater than 0, and that's greater than 0. So it's greater than 0 when k is less than minus 29 over 4, and when k is greater than minus 1. Okay, so if k is less than that and k is greater than minus 1, then you're going to get two distinct solutions where they intersect. Okay, and that's the end of the paper.